So let's learn what is a Docker multi-stage build. So to understand what is a Docker multi-stage build, let's take an example of a Spring Boot application. So I have very simple Spring Boot application here with a very single health controller, which is going to mention whether the system is up or running. That's it. And we have a Docker file here. Now, if we see this Docker file very carefully, it has two type of instruction. One instruction is to build this project, and other instructions are there to how to run this project. Okay, so whenever we are trying to build any project within our Docker file by giving such instructions, so we have to get a very big base image. Okay, so this base image has two parts. First, it is having all the build tools, and the other part, it also contains the Java 17 runtime environment as well. So this is a very big base image which we are using, and also we are copying all the source code inside it, and then we are running this specific instructions. So once we generate the artifact, right, and generate the base image generate the image out of it, it is going to be a very big base image. So let us understand it again using a very simple diagram. So we have taken a very big base image here, okay, which is containing all your build tools and the Java runtime environment. So it is having the compiler, dependencies, and all the tools. Then we have the source code, and using that source code and compiler, we are going to generate the artifact out of it. But the image which you generated is going to contain all your compiler, source code, and the artifact. But in reality, you only want the jar file to run your application. So, so that's the reason we use multi-stage build. So we'll come back to this definition later, but what it is trying to say is, so instead of using the entire big base image, we develop this in a single step, and using the artifact which is generated in this step, we are going to use it in the next step. Okay, so we'll demonstrate this using it on the Docker file. Okay, so but as a definition, we use multi-stage builds to create small, secure, and production ready Docker images by separating the build environment and the runtime environment. So let us build this image, and let us see the size of the specific image. Okay, so I have a Docker desktop here installed on my machine, and I'm going to go to this project directory, and I'm going to build the image. Okay, Docker build -t. I'm going to name it as, like, a single web. Okay, and I'm going to use a specific Docker file. It should be built. Okay, so let's run this. So okay, so this step took some time. You can see here all the instructions being executed, like copying the source code, running, building this project specific app actually took around 83 seconds. So you can see all the instructions are run successfully. So let us see the Docker images here. Docker images, and you can see the Docker image which is built here, and the size of that image is 590 MB. Okay, and also you can run this as an application. For example, you can use Docker run it in a detached mode. I will give it a name as single web only. Okay, and I'll run it in the port 9000 on my local host as 9001, and so it is running on 9000, and I'm going to use the name of the image, which is single web. So let us run this. Sorry, there's a typo here, so I'll just make it as single web. So let us check if it is started. Docker ps, and we can see this is running on port 9001. So you can just test it out locally. You can just go here, and you can use 9001, and you can see the system is coming up and running on 9001. So let us stop this using Docker stop, and let us go back to the discussion which we had earlier. So we can see that a single image, which is a very big fat image we took, and we went through all this instruction, and we could see that it is a very large image. It's having Maven, JDK, and all those dependencies, and it's also security risk because we are including the build tools. And startup also will be very slow because the size of the image itself is very huge, and it violates the least privilege principle. You can see the image it here. It is like, earlier I mentioned here the size of the image is around 590 MB here. That is what I was trying to mention here. Okay, so these are the problems with using a single stage build. So let us now move to the multi-stage build. So we are going to replace the Docker file using this instruction. So let us go through it one by one. So let us copy this, which I already created, and we are just going to paste it here. Now, if you can see, there are two set of instructions here. First step again is going to do a build. Okay, but in the next step, we are going to utilize the artifact which is generated in the earlier step here. So let us go to each of this step again here. In this instruction, we are using again a very big fat image, but you're mentioning as built. So we're going to use this only for building the package, not while running it. It won't be included when we generate the image. Okay, then we are using a new work directory as build, and then we are going to copy this pom.xml into this specific directory. I'll explain this step in the documentation. Then we are going to copy all the source code which is there in this specific folder dot source, and then we are going to run the command to build the package. So this is the first step, right? So let us go to the documentation here. Can you actually? So as a stage one, we are going to use as build to illustrate that this is a build step. This should not be included in the final image. So we have all these parts here. It includes the Maven as well as the full JDK, and we're going to mention this as a stage of the build. So this stage is not going to go into the production. That means as a final build. So we are going to copy pom.xml here in this. So what is the meaning of this specific statement here? So this, when you run the statements Maven dependency go offline, it is going to download all your dependencies upfront. Okay, so only when the pom.xml is changed, the dependencies are going to be re-downloaded. If your only code is changing, then only all your dependencies are reused. It's not going to download it again for you. And if your pom.xml is unchanged, it is not going to do a re-download again. So this is a step wherein for optimization purpose, we use this specific step. So the next step is very simple. We just copy all our source code inside this, and then on top of that, we run this specific command to compile it. It's going to compile it and it is going to run any test, and then it's going to produce this this specific jar which you want. Okay, so this is the first step which I wanted to mention here. So if you see, this is the first step, and this is all the Maven and the build tools are not going to be included in the file. So the next step, right, we are going to use a very slim base image. So this doesn't include any Maven tools. If you see the name here, Maven 3.96 Eclipse Trimmer. So this is only very slim image which contains only Java runtime environment of version 17. So here we're going to choose a new working directory, and then what we are going to do here is, so whatever we have done a build here, right? So in this specific path, right, we are at this specific path we ran this package. So on this specific path /target, all your Spring Web, the jar is going to be created using this command. So we're going to use this jar which is created in this step, like from build step, right? And we're going to go to this path, I have to copy it in apps dot slash. So basically, this step is just to copy that jar, and we're going to use this jar to create the image. So basically, the image is going to create it from this step itself. Okay, so it is going to be very small. So if you see here, only the purpose of this is to build a multi-stage build is to copy what is generated already in this build step. So this is not going to be included in your final image. So let us run this again. Okay, this time we are going to do a build minus t, and you have to mention this multi web, just to give it a different name, and then you're going to use a Docker file which we have updated this. So let us run this. So we are done with the building of the step. So you can see all the steps which are executed here, right? Right, like copying the pom.xml, again running this dependency, and then again running the build again, running the running the step to build the project and copying it. So let us check the Docker images. You can see the size of the image has reduced significantly. From 590 it has gone to 284 MB. So this is a stage 2 which I was explaining, that we have taken a very slim image, and it is only a GRE, it doesn't contain any compiler. It's of very smaller size. And again, we executed this step. We have copied the artifact from the build stage by using this command from build stage, and then we went to the specific location and then copied it here. And then okay, this step, as I mentioned, this copies it, George. All your Maven tools, source code, and the cache, all are discarded. The final images is clean. So if you see the more or less, this is just approximation of steps. So in our step, it was like from around 600, it went to around 284. Okay, so I got a 50% reduction. So normal you can get around around 75% reduction in the size of the image. So also we can run it as an application using the same build, okay, and which we have generated. Okay, we can just do this step as well. So we can use Docker run right in a detached mode and give it a name, like same name. I'll give it multi web, and then I'm going to run and port, let's say 9002, and I'm going to use 9000 uh, port of the Docker, and then I am going to give the name of the image, which is multi web here. So I think this should be fine. I think you should use here double quotes. Okay. Okay. Let's run this. Let's check it out. So it is running a 9002 port number. So let us go back here and check 9002. See, it is, so you can see now at 9002 also it's running up and running. So in the Docker desktop also you can just go and check your images here. We also here see the size of the images here which has been built. So yeah, so there are some benefits. Definitely we have a very smaller Docker image, so all the build tools are discarded, only the final app is kept. Since it is doesn't have any build tool or a source code, it is much secure and fast deployments, because the image sizes are very small and it starts fast. Clean runtime environment, so we'll include what is needed, like GRE and jar, very easy to debug and maintain. And also we are following the best practice because we are separating the build and the run responsibilities. Okay, and since the size of the image is low, uh, we have it is going to take less storage and less network transfer. It's ideal for CI/CD pipelines where we are going to build once and run anywhere, and it is consistent and reproducible builds. Definitely, it is avoiding unnecessary files, no source code, and all the build tools. It's production ready images because they are lightweight, they're very stable, and very secure.